Okay, what we're going to do in this presentation is we're going to find the Laplace transform of the following function. F of t equals sine of 3 pi t if t is between 0 and 2 and 0 otherwise. So essentially this is important, this bit, that the function is only active, so to speak, between 0 and 2. Okay? And after that it's 0. So it's only one particular region of the number line of the time frequency domains, or the time domain, where it actually is active. Okay, so between 0 and 2 essentially. It's okay. So how we could write that is we could use the Heaviside function, or I'm not actually 100% sure how to pronounce that, Heaviside or Heaviside. Bear with me. Anyway, so Heaviside. So what I'm going to what we could do there is rewrite that as between the starting point and the finishing point of where it is active. So it starts at time t equals 0 and finishes at time 2. Okay, and then just multiply that by the actual function itself. Okay, so it's a unit step function is the other name for this also, actually. So that's grand. So essentially what we're going to do there is, just as a remark, u of 0, u0 of t is equal to 1 always. Okay. Other ones actually, u infinity of t is equal to 0. Okay, there's a sort of way that you can sort of prove that out, which I'll look at in a different video. So essentially if we multiply this out and letting u of t equal to 1, we get f of t equals sine 3 pi t minus u2 of t sine 3 pi t. Great. Now, what I'm going to do here, so sine 3 pi of t actually is straightforward enough. We'll look at the tables for that. But this one is interesting. Okay, so what we have to do here is figure out what we can do about this. Okay, so I'm going to bring up my Laplace transform tables. Okay, table of Laplace transforms. And what I sort of pick out here is this, just underneath Heaviside function. So f of t minus a ua of t equals so essentially that if that is the function in the time domain, this is the function in the s domain, e to the minus as f of s. Okay, so what I'm going to do here, we have a u2 of t. What we're going to do is express the other function, the remainder, I'll just show you in a second, as f of t minus 2. So essentially what I want to do here is we can sort of like use that Laplace transform there. We have u of at, but what we need is f of t minus a, just to make the whole thing work. So what I'm going to do here is sine 3 pi t. What we're going to do here is express it as, break it up into two parts. Sine of 3 pi t minus 2 plus 6 pi. Okay? Now, this is the actual hard bit of the question. This is where the trick is. So what we're going to use here is a trigonometric identity. Sine of a plus b equals sine a cos b plus cos a sine b. Okay. Quite often, actually, you're usually given these sort of things in the mathematical tables if you're doing this sort of thing. Now, just as remarks, so sine a is sine 3 pi t minus 2. Okay, and b is 6 pi. Okay. Cos of 6 pi is equal to 1. Okay, and sine of 6 pi is equal to 0. Okay. So essentially, this entire second term, with a as 3 pi of t minus 2, 3 pi times t minus 2. Okay, so actually, if you actually sort of do all of this out, we have sine of 3 pi t minus 2 times 1 plus cos of 3 pi times t minus 2, 0. That old thing cancels out. That's a 1. In fact, all we are left with is sine 3 pi t equals sine 3 pi t minus 2. Now, actually, you probably might have guessed that anyway from the period of the function, but that does not always work in each case. So essentially a sort of more structured, rigorous approach usually would help there, because basically if you try to rely on just the fact that it periodicity of a trigonometric function, I find that people sort of muck it up. Okay, so what we are going to do now is f of t equals sine 3 pi of t minus u2t sine 3 pi t minus 2. Okay, and this is in the form gt minus u of at gt minus a. Okay. By the way, I'm just using G there just to sort of. It's actually F, but I'm just using it G instead of F just to sort of not confuse things. Partly because we use F in calling out the question. Okay. So essentially G is, let's just say, the given function. G for given function rather than F for function. Okay. So what we're going to do here, this is actually turns into a very straightforward calculation. Okay. So this is the f of t. So what we need is the Laplace transform of that, f of s. Okay, and that is sine of at. Actually, let's just sort of pick that out explicitly from the tables. Just bear with me. Here we have it there. Sine of at is a s squared plus a squared. It's a little bit hard to read that. I'll actually try and just sort of boost it closer to the screen. It's a bit blurry there. Hopefully that is okay. Yeah. Anyway. So a is equal to 3 pi. A squared is 9 pi squared. So we have the first part there is 3 pi over s squared plus 9 pi squared. Okay. G of t minus a. Essentially, this will work out the same way. We would actually use g of s here, just like we use g of s here, and e to the minus as, e to the minus 2s. Okay. Let me remind you what I mean about that. Just there underneath the Heaviside function. Okay, f of t minus a will actually correspond with capital F of s. Okay, and in this case, that's pretty much that. Okay, they're sort of used both at the same time. So we minus e to the minus 2s times that. So you can sort of simplify it as follows: 3 pi over s squared plus 9 pi squared. A little bit of a line just got drawn in there, but it's 9 pi squared. Times 1 minus e to the minus 2s. And that is our answer. Okay, that's it done. Good stuff.